All right, good morning, ladies and gentlemen. Today we're going to start off by playing with the Van der Graaf generator.
Van der Graaf generator.
Okay, so here we go.
Now, first of all, what it is,
Oh, yeah.
is you have a motor in the base that turns a wheel and makes this rubber, it's like a big rubber band, go around and around. It rubs electrons off the bottom and sends them up and puts them onto this. There is no connection between the wall plug and this. All the plug does is run the motor.
Mm-hmm.
So.
And then what is this thing right here?
Okay, that just goes to ground. That just is like, it's not a magic wand. It allows you to discharge the electrons from the ball into the earth.
Okay, let's try. And okay.
Why are those things standing up like that, Ms. Mo?
Huh. Should we answer this question now?
Please do, yeah.
Okay, so we said that electrons are running from the base to the top, right?
So there's a whole bunch of electrons on the top.
And so those electrons are running through the metal, through the string, and electrons are all negatively charged.
Yes.
And so they repel each other. They want to get as far away from possible from each other.
So that's a force acting on those red things as the electrons are repelling each other.
Okay, so what's going to happen if I bring this close? Ooh.
Let's turn the lights off.
Ooh, yeah. Turn them off. Okay. Woo! It's so pretty. Huh. Okay.
So we're getting big sparks.
There we go.
And then when you touch it with okay, that grounds it, and all the electrons go into the earth.
Here. Okay, so just to say that again, Mr. Boykin,
Yeah.
to repeat that, we said that the electrons are going from the base to the top here.
Carried by that rubber insulating belt.
Okay, just dropping them off at the
Yeah.
top of the hotel. And the electrons, they repel each other. They don't want to be by each other, so they're trying to spread out as much as possible. They spread through the string there and everything.
Yeah.
I'm trying to get as far as possible as from each other.
Well, they're hanging down right now because gravity's pulling them down.
Yeah, right.
And the force of repulsion is a force, and it's that force of repulsion where the electrons try to get away as far apart from each other as they can, that causes them to stand up.
And then when I brought this close to here,
Yeah.
this is a conductor, right?
It is. It's a conductor, yes.
Okay, and so we saw that those electrons were jumping from there to here.
Yep.
Right, trying to escape still.
Yeah,
Right, they want to try to get as far away from possible.
Yeah.
Okay, and then I touched it on like this to ground it. And again, we said that this wire goes to the ground.
Yeah, and you guys know on an electrical switch, there's the 3 prongs. You got these 2 that carry the electrical current, and then this one is the ground. It's the safety device that keeps you from being shocked in case there's a short circuit in the whatever the appliance is. And so the electrons from this go through here, into the base, into this, and then go into the earth through that part of the plug.
Okay, so let's do something else.
All right.
Bippity boppity boop. Okay, here we go.
Okay, now what you have here is a mylar ball,
Whoa!
and when it touches it, it picks up
Come on.
electrons,
Whoa.
and then
Whoa, that was cool.
it won't
Oh.
touch it anymore.
Uh-oh. There we go. Picked up
And
those
if you
electrons.
pull it away and then touch it, you discharge,
So,
you ground it. Now it's neutral, and you can bring it up,
there
and
we
it'll
go.
touch again.
That's a great, well, it did a really good job this time.
And then it stays
Okay.
away.
Whew! It's not really a shock. It's a and ground.
Sweet.
Okay.
In years past, here's a student who's standing on an insulator, who's got his hand on the Van der Graaf generator, and instead of the pieces of yarn going up, his hair's going up. But Put that cell phone away.
And so, Boykin, the important thing here is that when your hand is, when we do that kind of thing, your hand needs to be on here first, and then
you turn it on. Right.
Right. What would happen if they turned it on and then went to go touch it?
Swearing.
And so, so what was happening with this thing?
All right, gravity pulls it straight down. See,
Yeah.
gravity's pulling it straight down, and as soon as it touched that, it picked up electrons.
So it touches, because all those electrons in here, it wants a place to escape.
So
touches this. Now what charge is this now?
negatively charged.
Okay.
This is negatively charged. That's negatively charged. They repel each other. And that's why it was floating around on the outside. There was a force of repulsion keeping them apart.
Sweet. This is making sense. Okay. Oh, actually, before we do this, let's talk about the lab.
Oh, that's a good idea.
Ow.
It won't. It's not gonna.
Dang it. Okay. All right. So yesterday, we did the electroscope lab, and we did a couple things. Right. The first thing we did was we charged by conduction.
Yep.
Right. We came in and we made them. Oh, sorry, I touch it. Okay, we touched the top of the electroscope, and the electrons that are rubbed from here to here go on there. They travel down, and again, just like with the strings up there, they want to get as far away from each other as possible, so they all spread out and make the leaves split. Okay.
And so that's charging by conduction. And then go ahead.
And then I touch it, and all of the extra electrons that I had rubbed on there that were all spread out now escape through my finger, and they go back into the earth.
Yeah.
They're being grounded.
And unlike the Van de Graaff generator up there, this that has a really large number of electrons, you only have a few electrons, and it doesn't take much. This is a very sensitive instrument.
Yeah. And then the other thing we did was we charged by conduction. We did a grounding. Now I'm going to charge by induction. Okay. And for that one, we just get close.
Don't touch it.
Right. I'm not touching it.
Well, I think I heard a spark.
Oh, I did too. Yeah. Here, let me ground it. Okay. I like the. Okay. So charging my induction there.
Yep.
Okay. And then one thing. Okay. Good. And then the next thing that we did was we put it close like this, right?
Yep.
Put my finger on it, took it away, and then I move it away.
Yeah.
Okay, and it didn't do a great job of showing it there. But...
And it will touch the thing, see if it's charged. Yep. When you touched it, it moved. That's because there was some charge.
Mm-hmm.
We need to explain that.
Okay, let's talk about it. All right.
Now, we already gave them a definition of grounding, right? So
yeah,
go to the next slide, would you?
Okay.
And you already have this. That's
you guys know that electrons move into or out of a large reservoir of charge, us or the Earth.
Yeah.
When we touch it, it goes through us into the Earth,
Yeah.
and the Earth is neutral.
Yep.
It's so big, the charges that go in and out, they are overall neutral. Okay. And then we have a definition of induction, which we gave you guys yesterday as well. Induction: electrons are persuaded to move away from their neutral atoms by being attracted or repelled.
Okay, so let's explain what's going on.
Okay, so I'm going to go ahead and draw. Oh, it's a little bit high up there, actually. Let me grab this. Just a little lower. Okay. So when we first brought it close to, when we first brought the pipe close to the thing we were doing induction, the leaves kind of spread apart, right?
They did.
Okay. So spread apart like that, and let's say we're gonna say that our electroscope has 10 protons in it.
Sure.
Okay? And there's always gonna be 10 protons, no matter what.
It's in our diagram. Now, in reality, there are many, many, many more than that, but for our illustration, we'll use 10.
Right here, and then we'll put them over here and here. Okay, 6, 7, 8, 9, 10. Okay, boom. All right.
And then you've got the balloon that comes in close.
Yeah, and I know we didn't use an actual balloon, you guys, but I'm just gonna draw. This is our pipe, it's our balloon, whatever. Okay. So the first thing we do with our balloon is we rubbed it on our shirt, right?
Yep.
Okay. So that means that we had put Should I draw those negative charges right here?
On the outside.
On the outside right here. Okay, so we have these we have negative charged electrons, okay, on this outside right here. All right, and when we bring it close, here, oh, I need to draw my electrons in here, right?
Yep.
Okay, so I'm gonna say that I'm just gonna say, well, it's neutral, right? So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, right?
Okay, except why are the leaves spread apart?
Oh, they shouldn't be spread apart yet. Oh, why are the leaves spread apart? Oh,
Yeah.
that's a great question.
So some of those electrons that are up in the top.
Ooh, they're actually down here, you're right.
Yeah.
Okay, good catch.
So now there's more electrons and protons in the leaves and they spread apart.
Well, and I think I actually do this a little bit wrong too, because when we charge by induction, we're inducing a charge. We're persuading these protons and electrons to be near each other, right?
Well, the protons don't do anything. The electrons move.
The electrons.
And what you've got on the knob there is on the left, you've got negative charge. On the right, you have positive charge.
Yeah,
You've
and
induced
why is that?
a charge separation.
Yeah, these electrons are scaring these electrons
They
away.
run away,
and they're
run
pushing
away.
them over there. Yeah. Okay, so the protons, they stay where they're at.
Yeah.
And we have to have 10 electrons in here because it's neutral. We're not touching this, we're just bringing it close, and these electrons are scaring these ones away, and the two that would be in here normally in the beginning, they run down here, right? They get scared. Okay, they're trying to get as far away from that negative charge as possible. And so so we only have 1, 2, 3, 4 protons here. Okay, how many electrons?
6.
6, right? And so this has an overall down here negative charge.
Repulsion.
So we have those leaves that spread apart, we have repulsion. Okay, I think I talked about everything there that was important, yeah?
And in the video yesterday, they refer to that as induced separation of charge. You don't need to write that down.
We have excess electrons here, woohoo!
Yep.
Okay, and that's how we get that repulsion. Okay, good in that one?
Yep.
Okay. So did I want to I should go over the grounding one though.
Nope.
No, not yet?
No.
Okay.
Well, actually, you do the second one where you do ground it.
Yeah, okay. All right, so, I'm just going to take you through the different stages that we had here.
So we brought the balloon close, and what did we do after we brought the balloon close?
So that's when we put our finger on it, right?
Finger, so we'll draw the finger on when we get this.
Okay, so we put our finger on, okay, it's my nail, I think.
Yeah.
Okay, and the balloon is still here.
And the leaves just hang straight down.
And the leaves, yeah, they just hang straight down. So this thing that's going to be the same every single time is my number of protons.
Yep.
Okay, and over here I had 10 protons. So over here I need to also have 10 protons.
Yeah.
Okay, so I'm going to put them in the exact same spot. They're not moving. 5, 6, 7, 8, 9, 10. Okay, and when we first brought our we've got our thing here, our balloon, our pipe, really, PVC pipe that's inducing a charge here. And then we put our finger on it, okay? So what happens when we put our finger on it? That's grounding, right?
Yeah, that's grounding. Well, if the leaves are hanging straight down, it'll have the same number of electrons as protons on the leaf.
Yeah, because there's no repulsion there, right?
So that means we're going to have 4 electrons.
1, 2, 3, 4, okay, 5, 6, okay, 7, 8,
Now be careful, those electrons are not going to be anywhere near the balloon.
Yeah, I caught myself there. So that's 6 right there?
Yeah.
7, 8, 9, 10, but what's happening here with our finger?
Electrons, get the heck out of there.
Yeah, so you see these electrons here, and it's still scaring off those electrons.
You have to take some out of that knob. You got too many electrons in the knob.
So what happens here is, we did have 10 electrons originally, but they are like, they're like trying to get out of there, right? Okay, they're trying to go through the electron, through the finger, just like with our string on there, right?
Yep.
They went all the way to the ends of the string, and that is what grounding looks like.
So they go away, and then you pull your finger away, and you take the balloon away.
Right, so we'll do that one over here. Bada boom. Okay, and you know what, I forgot this one, we'll call this charging by induction.
Induction.
I hope you can see this orange. Really terrible. Okay, charging by induction. Okay, and so for this one, okay, now I'm taking that balloon away. Okay, the balloon is gonna be
Don't even draw
way
it.
over here. Oh yeah, I'll just take it out of the picture completely. Okay, and now my finger is gone too.
And
right?
the leaves are spread apart a little bit.
Yeah, and the leaves are still a little bit apart here. Okay, so I'm gonna draw my electrons in here. 1, 2, 3, 4, 5, 6. Well, I like this red better. 7, 8, 9, 10. But my electrons have left.
You're missing 4 electrons. That means you only have 6 electrons to go with your 10 protons.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8.
Nope.
Oh, sorry, 6.
No, you lost 4 electrons.
Okay.
So you can only have 6.
4, yeah. 1, 2, 3, 4, 5, 6. Bada boom. There we go.
All right.
Okay. So what do we notice about the leaves here? They're still being repelled. Okay, we still have repulsion here.
What kind of charge do we have now?
Okay, we have excess positive charge. So now we have excess positive charge.
And
okay?
that's charging by induction and using a balloon and a ground. And you charge by induction, you start off with a negative balloon and you end up with a positively charged electroscope.
Charged by induction. Boykin, let me make sure my electrons are right here, right? So 1, 2, 3, 4, 5, 6, 7. Should I have had 7 over here? I should take out that 6 one, huh? I'll take this guy off.
There you go. Because you've got 4 in the finger.
Yeah. Okay, and then this one. I know there's one here, but ignore that one.
All right, I think that's good enough.
I'm the chemistry teacher. I'm like, all right, they have to add up.
I know.
Okay.
Well,
all right. So, why does a negatively charged balloon stick to a neutral wall?
now we asked this question before, and there's kind of a hint right there. Let's go to the sim.
Okay. So we just got finished talking about charging by induction and grounding, right? So let's take a look at the simulation here. So take a look what's going on. You've got everything is neutral here.
Yeah, you got the blue electrons and the red protons, and every proton has 1 electron.
Okay, so I'm gonna go and just take off the charges for now. And I'm gonna go ahead and rub this on the shirt here, okay? I'm gonna let it go.
Okay, now it's attracted to the shirt.
Okay.
If it's attracted to the shirt, what can you say about the shirt?
Okay, well, the shirt must be positively charged then, right? They gotta be opposite charges there, right?
Opposite charge, yeah.
Okay, so then, can I get it to stick to the wall? Oh, there we go. It's gotta be close enough. Right there. Okay, so what's going on here?
That's a good question.
Let's take a look at the charges. Should I start from the beginning here for this?
Yeah, we'll remove it.
Okay. All right, so the first thing I do is I charge by conduction, right? I rub off.
Rub that.
Getting crazy over here, right? Okay.
So what's the charge on the sweater?
So the charge on the sweater is positive.
And where'd all those electrons go?
They're on the balloon, just like in our lab,
So
right?
when you let go of the balloon, it's attracting.
No, the protons stay where they're at.
But check out the wall. The wall is neutral. Every proton has, so why does the balloon stick to the...
Oh.
Oh, naked protons on the surface.
Naked protons. Okay, so it looks like
And what happens when you take the balloon away?
Come on. Oh, they go back.
The wall's neutral again.
Okay, so what it looks like to me is the balloon is inducing a charge on the wall, and the electrons that are the negatively charged balloon is pushing away, scaring away those electrons that are on the wall here.
Right at the surface.
At the surface, at the point of contact.
Yeah.
Right? And that's inducing a positive charge here, negative, and they attract.
That's right.
Right?
So it's an induced positive charge in the wall that's caused by scaring away some of those electrons. And as soon as you take the balloon away,
they go back. And
to
check this out when I go up and down. Woo! It's like the wave. Okay. All right. So that is what we're seeing here, and that's what we see right here, right?
Yep.
We bring that close here, those electrons get scared away.
Yep.
All right, here we go.
Now for something completely different.
Yeah, let's change it up.